All right, Bears. So we're continuing stoichiometry and going into the discussion about limiting reactants. On Friday, with most of my students, we talked about the definition and we worked out a problem. And I'm going to work the same problem, but I'm just recording it so you can see it again. Our definition for limiting reactant is the reactant present in the least amount, or the reactant that runs out first. And then the other definition that's part of this unit is excess reactant, the reactant that is remaining after the reaction is complete. And the excess reactant is what we have still left over. Didn't finish reacting because we ran out of our other reactant. Chemical reactions can only keep going until you run out of reactant. And typically in chemical reactions, we end up running out of one reactant before we do the other. And so the one we run out of first is obviously what we call limited, because as soon as it runs out, then the reaction can't occur anymore. And there's a way to calculate and figure out, based on, let's say, how many grams you are starting with of each of your reactants, that will allow us to determine which one we would run out of first. Okay, so we're gonna work this problem again. It's just a sample problem that we looked at in class. So I looked at with my class. Just to go over the steps for solving or trying to determine which one is our limiting reactant. So we always, no matter what, we'll always have to start with a balanced equation. And so I don't have that here. And my other concern too is that you might not be able to read cursive writing. I'm still trying to get used to using stylus on this. So I'll read them with you. So steps to solve for limiting reactants. Step number 1, we have to convert mass to moles by dividing by the molar mass. So, and again, I'm going to give you an example in just a second, and the steps will make more sense. Step 2 is we take those moles and divide it by its corresponding coefficient from the balanced equation. And step 3, looking at all of our reactants after we've done all of our conversions, we determine the smallest number, or we look for the smallest number, and that is in turn our limiting reactant. So let's take a look at our problem, and I don't have it balanced just yet, so we're going to do that so you can take a look at that as well. Let me move some of this around, sorry. Okay. So our problem is if you have 200 grams of, and S8 is, the name for S8 is cycloocta sulfur. We'll just call it sulfur. So if you have 200 grams of sulfur react with 100 grams of chlorine, what mass of disulfur dichloride is produced? Okay. So let's first balance, and our reactants here is that cyclooctasulfur, so S8, and we're going to react it with chlorine, because chlorine is Cl2, and our product will be disulfur dichloride. So let's balance this. I know there are different methods for balancing. There's something called the box method, which tends to confuse me. So I don't like to demonstrate the box method or demonstrate anything without completely knowing what exactly I'm doing. I'm just going to show you how to balance this, and this one's fairly easy to do. So we can see that on the reactant side, I have 8 sulfur, and I have 2 chlorine. On the product side, I have only 2 sulfur and 2 chlorine. So 2 and 2. Now, obviously, I can't do anything with my chlorine at this point because they're both balanced according to this. However, that's going to change as soon as I fix my sulfurs here. So I'm going to ask myself, okay, how many times will 2 go into 8? Well, 2 will go into 8 4 times. So 4 will then become my coefficient. Now, coefficients, when balancing, you can only add coefficients. You cannot add subscripts. Okay, so now that I have my 4 coefficient, I now have, if 4 times 2 is 8, I have now 8 sulfur, but I also have now 8 chlorine. So I need to go back to my reactant side and get that balanced. And I'm going to ask myself, how many times will 2 go into 8? Again, 2 goes into 8 4 times. And so 4 is my coefficient. So now I have my 8 chlorine on both sides. I have my 8 sulfur on both sides, and we are good to go. All right, I'm going to rewrite it because it was looking really crazy. Okay, so cycloocta sulfur. I'm going to get this right, I promise. Once I figure out how to do this. Okay. Cycloocta sulfur, S8, plus chlorine. And from our balanced equation, we had 4. And that will yield 4 disulfur dichloride. All right, there's our balanced equation. I'm going to highlight our coefficients because we're going to need those. And obviously there's not a number in front of sulfur, but when there's not a number, we assume there is 1. Okay, so let's get back to our problem. If you have 200 grams of S8 react with 100 grams of Cl2, what mass of disulfur dichloride is produced? Okay. So we're going to look at our steps real quick. Convert mass to moles by dividing by the molar mass. So I'm going to start with sulfur, or cycloocta sulfur. All right, you're going to need a calculator and a periodic table to do these calculations. So we need, in order to calculate the molar mass, because we're going to need the molar mass to figure out how many moles we have. And we see that sulfur here is 32.059. We're going to round that to 32.06 AMU, or in this case, grams per mole. So, let me move that out of the way. So our calculation, first we need to do the molar mass, 32.06 times. Now I need to multiply this by 8 because I have 8 of them. So I'm going to multiply that by 8. My calculator here. 32.06 times 8. And my total is 256.48 grams per mole. All right. Now I can convert the grams from my problem to figure out how many moles I actually have. So I'm going to set up my problem, and I'm going to use the picket fence or the railroad tracks, whatever you call it. And so I have to always start with my given from the problem. And according to my problem, I have 200 grams of cyclooctasulfur. So 200 grams of S8. And I calculated my molar mass to be 200. Let me be consistent here. 256.48 grams for every 1 mole of cyclooctasulfur. That's a funny name. All right. Now I can do my calculation. So I'm going to multiply my top, divide by my bottom. So 200, I'm putting this in my calculator, divided by 256.48. And my total here is 0. It says 0.7797. I'm going to round that to 0.78 moles. That's how many moles I have from my problem. All right. Now, my next step would be divide the moles by the corresponding coefficient. So now I need to refer back to my balanced equation. And I'm going to find my cyclooctasulfur and look for the coefficient in front of it to divide my moles by it. And here I have no number, so it's 1. So I'm going to do 0.78 divided by 1. And obviously my total then for sulfur is 0.78. Now this number has no units. We're just looking for a number so that we can compare to chlorine. And we're looking for the smallest number to determine if cyclooctasulfur is my limiting reagent or if chlorine is my limiting reagent for this problem. So I solve for my sulfur. I'm going to minimize this. And I'm going to, I'm going to now calculate for my chlorine. Okay. So chlorine, we need, again, we're going to go back and we need to calculate or figure out my molar mass for chlorine before I start. It's just easier to do it first. So according to my periodic table here, chlorine is 35.446 grams per mole for 1 chlorine. I'm going to round this to 35.45. And I need to multiply this by 2 because it's Cl2, not just Cl. So 35.45 times 2, I'll put that in my calculator, is 70.9 grams per mole. Alrighty. Alright, now I can go back to my problem and refer back, well, how many grams of chlorine am I starting with? And according to my problem, I'm starting with 100 grams. All right, 100 grams of Cl2 is what I'm starting with. And I know that in every 1 mole of Cl2, chlorine is 70.9 grams for every 1 mole of Cl2. And so I'm going to multiply my top, divide by my bottom. So I'm going to put in my calculator 100 divided by 70.9. And that total I get is 1.41 moles. That's how many moles of chlorine I have in 100 grams of chlorine. All right, now I'm on step 2, and I need to divide the moles by its corresponding coefficient. And according to my balanced equation, I have 4 moles of Cl2. All right, so I need to do 1.41 divided by 4. Let me see what my total is. And my total is 0.35. Okay, so now I've done my calculations for both problems here. Let me see if I can move some of this out of the way. And pull my other one back up. And that just would be way too easy, wouldn't it? But we can see it here. When I did my calculation for cyclooctasulfur, I ended up with a number 0.78. When I did chlorine, I ended up with my number being 0.35. And step number 3, it says the smallest number is the limiting reactant. So in this particular situation, I have my limiting reactant is going to be chlorine. All right, now, if we go back and we look at the problem, what it was asking us, and I'll read it again. If you have 200 grams of cyclooctasulfur react with 100 grams of chlorine, what mass of disulfur dichloride is produced? At this point, we have not answered the question, okay? We have to know which one is our limiting reactant, because if we want to know how much product we're going to make, well, we can only make as much as our limiting reactant. So I'm not going to have to work both of these problems out. Now is when I bring in my stoichiometry again. And so I'm going to bring in my stoichiometry, and my given number I'm going to use is the grams of the chlorine from the problem. All right, so if we wanted to actually answer the question that is given, we need to start first with the number it gives us. And again, since Cl2 is our limiting reactant, we're going to use this as our given. So 100 grams of Cl2. I already did this calculation earlier when I was trying to figure out, well, how many moles is in that? I have to convert to my moles so I can then bring in my mole ratio and then multiply that by the molar mass of my unknown. So I've already done it, but I'm gonna do it again just in case you wanted to see it again. So I'm going to do a mass to mass. So I need to put in my 70.9 grams of Cl2. This is my molar mass of chlorine for every 1 mole of Cl2. All right. At this point, if I was to stop at calculating, I would only have calculated how many moles are in 100 grams of chlorine. I'm trying to get all the way to disulfur dichloride, sorry. And so I need my mole ratio. What is my mole ratio of chlorine to disulfur dichloride? It's 4 to 4. So 4 will go down here, 4 moles of Cl2 for every 4 moles of disulfur dichloride. At this point, if I was to stop now and just do this calculation, I would only know how many moles of disulfur dichloride I could produce. The problem is not asking for how many moles. It's asking for mass, even though that's difficult writing to read. It's asking for the mass. So I need to calculate the mass, the molar mass of disulfur dichloride. Okay, I already know the mass of Cl2. So really all I need to do is figure out then my sulfur. And again, the sulfur is 32.06. So I want to show you all these steps. 32.06 times 2 plus 35.45 times 2. This is going to be my molar mass of disulfur dichloride. I'm going to put that in my calculator. 32.06 times 2 plus 70.9. So my total molar mass for disulfur dichloride is 135.02 grams per mole. Okay. So I'm going to, for every 1 mole of disulfur dichloride, I have 135.02 grams. All right. I'm going to tell you guys the same thing I've told my students. Let me move this over so you can see the whole thing. If you have the same numbers, and you know this from math, from your Algebra 1, if you have the same numbers on the top as on the bottom, well, they cancel out. So always look for that. It makes calculating so much more easier when you're already having to put all these numbers in your calculator. It's easy to make a mistake here or there. So try eliminating some of the numbers by seeing if there's anything on the top and the bottom that's the same that you can cancel out. Obviously the ones don't even really matter. You never have to put those in. But just for the sake of just trying to show you that they cancel out, I'll cross them out. So really all we need to do is multiply the top and divide by the bottom. So I'm going to do 100 times 135.02 equals, and then I'm going to divide that by 70.9. And my total, let me move this. I have too much going on here. I don't want to confuse you. My total then, my answer would be 190.44 grams of disulfur dichloride. All right. Uh, I always like my students to put it back into the problem. Let's put it back into the problem. Let's make sure we answered this correctly. And I can't. Here we go. Okay. My problem said, if you have 200 grams of cyclooctasulfur react with 100 grams of chlorine, what mass of disulfur dichloride is produced? We did our first step, balance the equation. Then we determined, okay, which one of these am I going to use? Am I going to use the 200 grams of cyclooctasulfur, or am I going to use 100 grams of Cl2 to solve this problem? And we have to determine which one of those is my limiting reactant to determine which one I'm going to use. Once we determined that chlorine was our limiting reactant, so that is going to be our starting grams. That's going to be our known, and that's what we did here. Okay. We ended up with an answer of 190.44. Okay, so if I had 100 grams of chlorine, then I would be able to produce 190.44 grams of disulfur dichloride. That's what we just solved for. Okay. If you have any questions, leave your comments. And I will get to them in class. We're going to continue working on this. I just wanted to make sure that you had got to see it again, just in case you had any questions. This is just another step building onto what we've already been doing. And the steps are, again, fairly easy. Convert the mass to moles, divide the moles by the coefficient, and then whichever number is the smallest one, that's our limiting reactant, where we can only produce as much product as what our limiting reactant allows.